So I'm very pleased to introduce today's speaker, Dev Rishi with Predabase. Dev is co-founder and chief product officer for Predabase, a company redefining ML tooling with a declarative approach. Prior to Predabase, he was an ML PM at Google, working across products like Firebase, Google Research, and the Google Assistant, as well as Vertex AI. While there, Dev was also the first product manager for Kaggle, a data science and machine learning community with over 8 million users worldwide. Dev's academic background is in computer science and statistics, and he holds a master's in computer science from Harvard University, focused on machine learning. Thanks for being with us today, Dev. We're looking forward to your presentation. Building ML solutions from scratch is a challenge. Complex low-level code and long dev cycles make it hard to deploy a single model in less than 6 months. On the other hand, existing commercial AutoML solutions lack flexibility and support for unstructured data, and typically don't perform well for complex deep learning use cases. A new generation of AutoML technologies, like those pioneered at Uber, Apple, and Meta, aim to change that. These declarative machine learning systems provide a glass box approach to automating ML that enables data teams to bring new models to market faster with complete flexibility and control, and the power to work with unstructured data sets for a broad range of use cases like NLP and computer vision. In today's Data Science Central webinar, you'll learn why current AutoML solutions fall short, what are declarative ML systems with a deep dive on open source Ludwig from Uber, how to build state-of-the-art deep learning models in less than 15 lines of code with a config-driven approach, and how to rapidly train, iterate, and deploy an ML model on structured and unstructured data with Ludwig and Predabase. Dev, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Thanks very much, Sean, for a great introduction. Hello, everyone. I'm Dev. As Sean mentioned, I'm one of the co-founders of Predabase, a low-code machine learning platform. And today I'm excited to talk a little bit about the future of automated machine learning. In particular, we're going to cover, the promise that it held, the trough of disillusionment that I think it's lived in since, and the 2-dot approach that we think is here to save the day and actually work. Now, as Sean mentioned, my background is as a product lead across a number of teams at Google, working directly on machine learning. But more broadly at the Predabase organization, a lot of us are passionate about this problem of trying to increase the access of machine learning, because we come from a number of organizations that really generated high ROI from ML. So, our co-founders come from companies like Uber, Google, Apple, Meta, Facebook, and others. And one of the key things that was consistent is we saw how machine learning was able to lead to much higher user retention, growth, value, and then ultimately top-line revenue as well. But the main thing that we notice is that these types of leading tech companies that get high ROI from AI are also the ones that are able to make disproportionate or oversized investments in machine learning. They've been able to hire historically the experts in data science fields and invest heavily in ML infrastructure and tooling that they themselves will often build internally. Most other organizations that we've seen, worked with, or even worked at, 90% plus of other organizations are still in an ML experimentation phase. They can see where they would be able to get value from the use cases for which machine learning would be effective in the organization. But I wouldn't say many of them are necessarily generating really strong ROI from those AI projects today. And I think one of the main reasons for that is just the starting cost and the investment cost and the time horizon for most machine learning projects, as well as the limitation about who can actually get access towards them. And this problem isn't really new. Starting back over a decade ago, if we just look at the tweets around democratizing machine learning, it's been obvious to, I think, a broad community that ML would be a lot more powerful once it's in the hands of a lot more users. And as a result of that, I think we've seen a class of products that look to deliver on that promise. And each year, it actually feels like there are more and more products trying to hit that same vision of democratizing access to ML. And I think that's because the pain organizations feel is so strong. But one of the key things that we've observed is that all of these products year in year, the additional ones that come to the market that look to do this more or less take the same approach to the problem. And I actually, know this firsthand because I was one of those people. Back in 2019, I led a project to introduce Google's AutoML to the Kaggle community. Kaggle is a data science and machine learning community overall, which at the time numbered 3.5 million users with hundreds of thousands of monthly active users that would train and share ML models frequently. It was the perfect moment and the perfect audience to try and bring this approach to AutoML to a mainstream audience. And pretty immediately after we, thought about this idea and put together some of the initial integrations, there were plenty of reasons to get excited. We actually got picked up in the press for hosting a one-day competition where we had Google's AutoML and data scientists in the same room competing on a particular task, a machine learning competition. And that allowed us to see where AutoML excelled, in particular, how it gave people superpowers initially. Now even the more novice data scientists in the room were able to get much more advanced models than they might have been able to create themselves. And it provided that same group of folks some structure. They understood that what they were doing was likely the best practices, and it felt a little bit less like the Wild West that normal modeling might. So, with all of that hype where we saw this potential promise of Google AutoML from a one-day competition and the press that we got afterwards, we were really excited to see how it would perform organically in the community. And so we launched the native AutoML integration into the Kaggle platform. And here's a little bit of how it went. AutoML's general usage performed approximately like this. At first, there was a lot of popularity and uptake. And part of that was we were pushing it pretty aggressively. But also, a lot of users saw kind of the initial promise. But the churn was really high, and we never saw it take off. The majority of users that we saw try AutoML left the product within weeks or a few months. And so, we wanted to understand why both Google's AutoML and countless other AutoML products that have been introduced into the Kaggle community and into the machine learning community at large haven't really taken off. So what we're going to do is try and understand that directly from the lens of users, customers, and what researchers have found, and kind of understand what the gap is between the promise of being able to open up access to machine learning and the reality. So this is going to be specifically about, AutoML and where it may have fallen short of users' expectations. What we saw from the community was something that we summarized as a dead-end problem that became a showstopper for them. This was one of the most common types of questions we saw from users as they experimented with machine learning. Great, I've gotten my first model. What can I do next? How do I improve predictions with AutoML? Now, of course, AutoML 1.0 in kind of the vast majority of instantiations is a kind of a push button approach. You click a button, you get a model, and then you directly decide to use it. And so the idea that you don't actually need to or can do anything further was considered a feature. But and I think if we look back and reflect on the data science journey, that's pretty incongruous to how most of us develop models today. In data science, our first model is very rarely our last. And so despite the fact that AutoML might have helped users get started with models quite quickly, it was a no-go if there was nothing that they could iterate on afterwards. Maybe it was a good start, but it was rarely good enough. And we hear this same type of sentiment reflected from the customers that we've worked with as well, which is, this is probably the most common type of thing that we hear from a customer, that AutoML is great to build a quick prototype. It's easy for, someone to be able to build a very initial model off of, but they never use it for anything serious. In fact, one of our customers referred to the class of AutoML products as something that's a little bit more like a toy. And I think one of the main reasons for that is that it lacks the agency and the control and the full flexibility that they need for their more serious production applications. And we can actually see, the best summary of what the industry says are the pain points of AutoML, because there was a group of researchers from UC Berkeley that studied this problem in depth. And they did user interviews with dozens of practitioners who had varying degrees of AutoML. And I think, came away with 3 key takeaways of, despite the fact that it held a lot of promise, what was stopping it from the actual eventual adoption. Those three key takeaways might be familiar to you if some of you have had a chance to try AutoML systems. The first was that AutoML was considered a black box. So you had limited visibility into what the actual internals of the modeling interface was, and very limited agency over those as well. The second was that AutoML often suffered from a dead-end problem. And because a dead-end problem essentially meant once you hit that ceiling of what the AutoML model could give you, there wasn't a lot of ways that you could work around it. And so most customers reported that at a certain point, once there's a mission critical project, they had to throw AutoML out the window and then switch back to complete manual development for that increased agency and control. And finally, customers are, of course, worried about any limited support the platform might have, especially anything that leads to lock-in. So, how do we this help on data pre-processing is something we hear quite frequent with customers. And then what's the takeout story, in particular with some of the commercial offerings. My favorite takeaway from this paper is that honestly, just the vision of AutoML 1.0 was off. So, contrary to what I think some of the initial folks that had thought about this problem was looking for, no one was looking for a push button solution that just gave you a model and then, told you to go off and put it into production. Instead, users wanted to get into the trenches with AutoML. They want to be able to work side by side with the system in a more human in the loop way that would assist them without limiting them. And so I think this kind of really summarizes what the gap was between the promise that AutoML had for democratizing machine learning, and when you actually put it in the hands of customers and users, what they reacted to and saw. So let's go to back to the other end of the extreme. We know that those 10% of companies were effectively tackling more and more ML projects every day. Is there anything that we can learn from in terms of how they architected their own internal machine learning platforms? The first thing that I want to note that's interesting is that democratizing access was a priority for these companies. In fact, you can see this, quote from a blog post released from Meta, formerly Facebook, detailing their internal ML platform, where they say that the system that they want to build for their ML platform must accommodate engineers without backgrounds in machine learning and provide mechanisms to optimize for many different product goals. And I think you'll see the same type of sentiment reflected in the internal ML platforms of many of the other leading tech companies. And I think that the way that they decided to be able to democratize access towards machine learning internally was to take a declarative approach to ML. They took an approach that had worked for them historically, simplifying other parts of complex infrastructure. For example, how Kubernetes would simplify a large part of their workloads, especially as they set up cloud infra. And they used that same pattern to start to package machine learning behind an interface that would make it a lot more accessible inside of an organization. Now, I know this story intimately, and I'll take a moment to brag on behalf of two of my co-founders, Chris and Piero, who actually developed these approaches independently while they were at their respective companies, Apple and Uber. What's really interesting to me is that these three companies that all kind of lead the field in machine learning essentially converged on the same approach, despite the fact that they worked, independently on it. And I think that's because they were actively looking to solve their own problem. They knew that they had engineers that needed to be able to get access to ML internally, and they all converged on a similar approach of how they were going to do it. Now, Piero's project Ludwig is the open source declarative interface. And so I'm going to use that as an opportunity to show you a little bit more of what I mean when I say declarative machine learning. The key idea behind declarative machine learning is that it's going to make it very easy for you to get started by allowing you to focus on the what and the system to focus on the how. So it makes it very easy to get started, but gives you the full level of control and flexibility that you might need by packaging the entire set of possibilities behind a configuration interface. So this is a Ludwig configuration as an example. And again, Ludwig is the open source declarative machine learning project. In Ludwig, this 6-line configuration can set up an end-to-end machine learning pipeline to build a state-of-the-art text classification model. It'll automatically set up data set pre-processing pipelines, encode your different types of data that you might have, including multimodal data that could include numerical, tabular, and categorical data, as well as text, images, audio, geographic locations, dates, and time series, and then do and apply the same thing for your post-processing timeline. And so you can easily get, the decoded predictions at the end of it. It'll also set up, of course, your full model, not only the definition of the model, but the training loop that is required to be able to train it and the infrastructure that would need to run on. Best of all, you can always customize any parts of the pipeline you need in a series of one-line declarative statements. And I think that functionality is actually critical to making the system a little bit more human in the loop and being able to make sure that there isn't that dead-end problem. Because with traditional AutoML systems, customizing your model is very painful. It means throwing away the system that you had entirely and starting from scratch so you can write low-level code. Here's the obligatory slide that you'll see in presentations about how complex that can get. Building even the preliminary parts of data pre-processing requires complex wrangling. You'll have to do feature normalizations, scaling, maybe build a vocab, do text tokenization, many other things, just in order to get your data set in a format that it's ready for machine learning. And then you actually get to the internal guts of your model. A popular one, like an LSTM, a particular form of neural network, can mean hundreds of lines of bespoke code just to be able to define the model that you want to be able to use. And then you have, the work that you need to be able to do in order to write your training loop and train the model. And this is, again, considering, nothing else beyond just training your first model. We haven't even talked about iterating on models, the infrastructure that you need to set up in order to be able to run this bespoke code, debugging, model serving, and many other things. Instead of writing all of this code that you need in order to customize your pipeline, in Ludwig, you can essentially just replace that with the following 2 lines that say, I want to use my own custom encoder, and the type of encoder I want to use is an LSTM. So the way that we see this is that this massively increases the access that users can have directly towards a system that allows them to get state-of-the-art capabilities and preserve the flexibility while removing the complexity. And therefore, we kind of think of declarative machine learning as the next generation of AutoML. It's the AutoML 2.0, where the 1.0 approaches were just the starting point. You still get your fully customized machine learning model out of the box for you, but the key idea is that it's all fully configurable and gives you the access that we think customers need. So if I had to summarize the 2 different approaches that organizations use to build ML models today, I might try and compare them using an analogy to 2 different ways that someone might make coffee. On the left-hand side, we have building things with low-level APIs, something like maybe a PyTorch or TensorFlow. If I were making my own coffee this way, that would mean I'd need to grind all of my beans directly. I'd have to have all the right equipment. And even in the best case, it would take several hours outside of my morning. On the right-hand side, the AutoML approach, we have things like instant coffee. It might work as a quick fix, but no one actually really wants instant coffee. Instead, we think of declarative machine learning like ordering coffee on the Starbucks app. You'll get started with a number of base templates that work really well, and then you can customize that you want the way that you want. You don't need to source your vanilla in order to be able to add it to your coffee. You just say in a 1-line statement, this is what I want to be able to do, and the app allows you to customize what you want and then leave the rest. And so our view is that declarative machine learning, essentially bridges both the benefits of the flexibility of low-level APIs and the simplicity of AutoML. And so if we were to reflect for a moment then on what we saw previously as the gaps that the research showed on machine learning of traditional AutoML 1.0 being a black box, suffering from a dead-end problem, and having that limited support and lock-in, we can see that instead of a black box, declarative machine learning takes a glass box approach. You still get the model out of the box, to use the analogy, but you can configure it down to the level of code. You can change any part of the pipeline you want. It becomes very easy to customize. Instead of being a dead-end problem, declarative machine learning is all about being a human in the loop. It's really around, iterative machine learning versus automated machine learning. And it's fully extensible as well. And then finally, if you look at the limited support and lock-in, instead, we think about ours as being end-to-end and open. So it starts with the data pre-processing and critically is built on top of open source foundations. So you can always take your models out and use them in any other setup that you'd want. Being open also allows us to be even more extensible, which means if you see a module in there that we perhaps don't already have inside of a framework like Ludwig, you can always extend it to be able to include any custom code that you want to be able to use. Now, Ludwig as a declarative modeling interface, has gotten pretty popular. But I want to make sure to briefly emphasize that it's more than actually just a pretty interface towards machine learning. Ludwig not only has a deep configuration language that allows you to customize and extend the modules that you might need, it allows you to get a heavy degree of expert control that really allows you to do more advanced features, especially as your sophistication as a user increases. For example, with the expert level of control, you can use state-of-the-art and cutting-edge, new models and model architectures, ones that you might have heard of, like BERT or GPT and others. And you get, of course, all this functionality that we believe even the more expert data scientists might need, like full-fledged hyperparameter optimization that supports a number of different strategies. One of the most interesting things about Ludwig is that, beyond the interface, it also sits on top of a novel compositional model architecture. And in this next slide, I can show you how this works. What Ludwig does is it creates these series of machine learning pipelines directly for you, again, that are fully customizable. And the really innovative thing about these pipelines is that they can be combined in different ways to give you state-of-the-art models. So you can use things like T5, transformer models, GPT, all in conjunction with each other in order to be able to do many different types of tasks, from multivariable regression to computer vision to text classification. And the really interesting thing is you can see that the very short configuration on the left, something that's just fitting into a relatively small slide, can create all of these different combinations of both machine learning tasks as well as state-of-the-art models that can tackle those tasks. And so Ludwig really is bringing you a lot of flexibility, the best of breed of what's out there in terms of like the modeling interfaces, and a consistent but simple way to be able to both build those models initially and continue to iterate off of them. Now, at this point, I hope you're thinking, declarative machine learning is great. But some of you might be ready and wondering, is it ready for prime time yet? I can imagine a few questions that come up. The first might be, hey, that configuration language is easier than building machine learning, but it still doesn't look easy enough. You can see that. I could also see like a number of folks recognizing that, beyond just generating those configurations, there's more to models than being able to define what you want. You have to think about infrastructure, data connectors. You have to think about your end-to-end journey, tracking, model experimentation, and then serving and deploying those, of course, as well. And so if declarative ML, is a promise, is it ready for prime time? And so at Predabase, what we're looking to build is a commercial and enterprise-ready platform that's the fastest way to go from data deployment. And what we do is we take the core idea that Ludwig provides, that you can declaratively train models with all of the benefits that we just covered from the glass box approach, the simplicity and flexibility, and build an end-to-end machine learning platform around it, around this core nugget. And end-to-end ML platforms means we start with the data and connect a number of the data sources that you might want to be able to build from, allow you to be able to not only build these models iteratively, but be able to track their progress over time, and then have a story for how you can deploy those models too, either for batch predictions or for real-time inference as well. It means tackling and handling the ugly parts of machine learning infrastructure as well, and building a fully scalable managed ML infrastructure service that can deploy on any of the major US cloud environments. And it means being able to package all of this behind interfaces that become accessible across a number of the types of users that an organization might have or teams might have. And so that's a little bit of the, the vision of what we've wanted to set out to be able to actually bring that same secret sauce declarative machine learning that we saw lead a lot of the tech companies and how they developed their internal platforms, and bring it to something that actually would be open up to a much broader audience. And so with that, what I can do is switch over to a bit of a live demo where I can show you exactly how this works in practice. So give me one moment as I transition over to our demo. Excellent. So here you'll be able to see the Predabase platform in action. And you'll, the first thing I want to emphasize is in this demo, I'll be going through our graphical user interface. But we also support our entire journey through an SDK as well, if you wanted to access this functionality programmatically. I'll be showing you through the interface just because it's a little bit more expressive in terms of the capabilities that you have. Now, there's a few key user journeys that someone might do once they get into the Predabase platform. The first thing they'll want to do is connect data. Then you can get to the fun part of building and training these models declaratively, and I'll show you a little of how that works. And then finally, you can query the models in order to be able to operationalize them live. Now, connecting data is relatively straightforward in Predabase. Essentially, connecting data means just going to any one of our a number of our cloud data connectors and entering the credentials that you might be interested in being able to pull that data from. The useful thing to know is that Predabase and Ludwig both are particularly good at handling unstructured data. And therefore, we support both your normal tabular data warehouses, something like a Redshift or Snowflake, but also unstructured object storage like Google Cloud Storage or with Databricks Delta Lake that might work with a more lakehouse architecture. Today, the dataset that I want to walk you through is called the TwitterBots dataset. And the TwitterBots dataset, I'll just show you a very brief preview of, is a fun one, I think, that we'll be able to talk through. It's essentially a dataset where each row is a Twitter user profile. And you can see that I have a lot of information about each Twitter user profile, including structured information about that profile, like how many favorites, followers, friends I have, less structured information, like the text description that a user might have written for themselves in their bio. And what I say is sometimes really unstructured information, like the profile picture image that a user might decide to use for their profile. And of course, you might be able to guess from either the news or the name of the dataset. What we're going to try and do is predict whether or not this user is a human or a bot. So this is a multimodal dataset and a machine learning task that we have set up. I'm going to show you a little bit about how Predabase makes it easy to both tackle and iterate on this type of problem. So once I've connected the data, I can get to the more fun and interesting part of building the ML models to tackle them. Now, in Predabase, we have this concept that we call a model repository. And a model repo, for short, is essentially our attempt to be able to bring some of the best practices from engineering and Git into the ML development lifecycle. And so if I clicked into a model repo, you can see it's essentially a collection of machine learning models, all oriented towards solving a particular task. And so here's the set of models that I have for the TwitterBots model task. Let me show you how easy it is to build your first model. All I'll do is click, I want to train a new model, and I'll select where my data set is coming from. The first thing you'll notice is that we'll recommend a model type and architecture. You don't need to change any of these settings necessarily. And you'll be able to see all the features that get extracted from this model. So you can see we have those things like the text description, the profile picture images, how many friends they have, and then finally this column that we want to predict called the account type. All you need to do as a user is specify the target that you want to predict. So in this case, I want to predict the account type. You'll see the next button gets flagged. And we've automatically set up your entire ML pipeline for you. To tie this back to the Ludwig open source declarative configuration you saw, you can actually just click into the config. What we've done is automatically generated your starter configuration, our recommendation for you based on the data set that you have and the compute that you're running on what we think makes the most sense for the task that you're interested in. And you can see we often have like basic default settings that are good for getting your first model very quickly, and then a way to be able to get a better performing configuration if you're interested as well. So this configuration maps one-to-one with the ML pipeline graph that I'm showing you here. And so if I were to zoom in, what you can actually see is you can see what's actually happening under the hood for each of these tasks. So on the left-hand side, I have each of my input features. So I have things like the description, profile picture image, favorite, followers, friends, that then pass through a series of machine learning pipelines that pre-process the data and then encode them with a series of ML models, and then come out with a prediction on the other end. The really neat thing is any part of this pipeline is customizable. Because it's all backed by configuration interface, in Predabase, I can actually just click in and change anything that I might want. For example, I could change how the text is tokenized, or the maximum sequence length, or how I want to handle things like missing values. You can see that one thing we've tried to do is impart of a lot of the expertise we have on our team in terms of what our default settings are, and then also what our suggested is based on the data set that you might have. And we try to give you some context for every single setting that you might want to have. You can also get access to a number of our cutting edge state-of-the-art models as well. So, something like a T5 or BERT or Stack CNN, transformer architectures, GPT, GPT-2 are a number of the types of models that are directly supported in our platform. And the really, really interesting thing is that you can actually use, let's say, a BERT model to be able to encode the text field, and then a different but cutting edge model as well, maybe something like an efficient net to encode the image field. And now I can actually use these compositionally directly in my model itself. So I've taken the best-in-class model that I have for text and the best-in-class model that is available for images, and I'm combining them directly together into one centralized machine learning modeling pipeline. And I didn't need to implement a thing in order to be able to do it. All I did was make a few selections from a drop-down menu that honestly, maybe I even clicked through too quickly. Now, I want to emphasize that the vast majority of our users really appreciate that there is a lot of flexibility in this platform in terms of the types of things that you can edit. But the way that almost all of them get started, I'm just showing you some of that functionality here. But the way that all of them essentially get started is they work through our suggested model first. So the vast majority of our users will first train whatever the model is that Predabase recommends, and from there customize either one thing at a time, aka changing something like an encoder, or decide that they want to run a much larger hyperop sweep, in which case they might decide that they want Predabase to explore a series of parameters, for example, the optimal parameters that they might be interested in looking for over the learning rate. So while this flexibility is really, really powerful, you can use it more tactically, like a surgical knife, in order to be able to understand the parts of the pipeline you want to be able to control and allow the system to be able to automate the rest. Once you have a model configuration that you're happy with, you can easily train that model, and we'll handle all the infrastructure for scaling that out. We have this abstraction on top of compute that we call engines. Engines are basically a way for us to be able to simplify the best practices in distributed machine learning infra and make it available to you in a prepackaged concept in one click. We right-size the compute to your task. And so we suggest what we think is the right compute settings that will optimally and efficiently use GPUs and CPUs. And you'll never have to worry about things like CUDA or compute selections itself. However, like everything in Predabase, you can always override our selections as well and customize as you'd want. Once you've had a chance and you're happy with your model and the configuration that drives it, you can go back into the model repository, see it train, and you can also click into any individual version to get its metrics. Over time, a model repository allows you to see the different versions that a user or a group of users, like a team, might be doing to collaborate exactly on a particular task. So here you can see that a number of users have gotten involved in this machine learning task and been able to kind of iterate together on what they want to be able to get to as a final result. One of the really powerful things about being able to also treat a model as a configuration is that it becomes very easy to diff two model versions. So for example, just because these are just configuration files, I can easily diff model version 2 and model version 8. And I can see that the key difference between these two models is that on model version 8, I decided to use a BERT encoder, which is a large language model, and as well as increase the number of layers that I have in my network and lower the learning rate. So this is an easy way for me to be able to diff model versions over time and be able to get a good sense of what those how those might vary and where they might explain experiment differences that I might see. Once you have a model version that you're happy with, you can click into it and get a full report of its metrics. So we show you everything from accuracy, AUC, loss, precision, recall, any of the metrics that you might care about are available directly for you from this screen. You can also get a sense of the standard things that you might care about, like confusion matrices, that help you understand how exactly it performed on this particular classification task, or something that's definitely popular with a lot of our customers in terms of feature importance. And the really interesting thing is with feature importance, I can also understand that, hey, the text description was one of the top 3 functionalities that mattered for this particular model as it was coming up with its predictions, I can get into and click and understand for, give an example, what were the tokens that were being highlighted or the words that were being highlighted by the model as pushing it in one way or the other. Now, once I have a model that, again, let's imagine I've looked at all the metrics, I'm happy with it, I've collaborated with my team on being able to train it, and now I want to operationalize it. This is the second half of the modeling journey, and 90% of models probably fail before they actually get to this point. But once you're ready to put it into production, and hopefully you've been able to get here pretty quickly with Predabase, you can now think about how you want to operationalize it. And there's 3 ways you can think about that in Predabase. The first is if you have your own bespoke serving stack and you want to just run it locally, or you want to take the model out of Predabase. As I mentioned before, you can always export models out. We support a number of different export formats directly inside the platform. If you want to instead deploy it to an endpoint in one click, and be able to get a REST endpoint that you can then use as an API for a downstream application, you can deploy it to an endpoint, just giving it a name, and we'll automatically create an API for it for you. Or if you're interested in doing batch prediction, we have a pretty novel interface that allows users to be able to run machine learning directly on top of their data. And I'll show you a little bit of what that looks like here. This interface for batch prediction is something we call Pequel. And Pequel is just this slight extension on top of SQL that allows us to put machine learning directly on top of the data. And so because it's a slight extension to SQL, I can run my conventional SQL queries, like select 10 users from the Twitter bots data set here. And you can see I have that same list of Twitter user accounts with the account type on the far right-hand side here. The really cool thing about Pequel is I can augment this query by doing something as simple as predict the account type, predict the column that I care about, that I trained a model for, given these 10 users. And now we've essentially translated this standard analytical SQL query that users run hundreds of times every day and changed it to a predictive query in one additional line. And when this query executes, what you'll see is we add an additional column to the far right-hand side of the output table. And that column is going to contain the account type predictions, or the predictions that are coming directly from the ML model itself. So here I can see, when I compare account type and the account type predictions from the model, in most cases, the model did well. And in some cases, there might be some room for improvement as well. Pequel itself is a very rich interface that we think is helpful to give even more users across an organization access to machine learning predictions. And it's also something that is very extensible. So if you wanted to get not only the prediction, but the likelihood of the prediction as well, you could predict with confidence. Or one of our customer favorites is probably the idea of being able to predict with explanation. And what explanation is going to do is something quite similar to what you saw earlier, which is give you a sense of the key factors that are driving the model's prediction in one way or the other. But one of the interesting things about running this type of query, directly in Pequel is that it can also give you access towards those results at an individual row level. And so I can look at any of these individual Twitter user profiles and get a sense as for like this particular row or this particular profile, what were the factors pushing up or down this individual model's likelihood of being classified as a bot or a human. And again, I can also click into unstructured data like the text and get a sense of like what were the factors that were really moving it in one way or the other in terms of how the model thought about classifying this user as a human or a bot. So as a brief recap, this is a little bit about the Predabase platform and more generally declarative machine learning and why we believe it's the next generation that will deliver on the promise that automated machine learning had of democratizing access to machine learning. The key thing that we want to be able to emphasize is that by taking a declarative approach that was originally pioneered by some of these leading tech companies, we're able to increase access by bringing by bringing the best of simplicity and complexity to a lot of users directly. You can get started with the kind of core nugget around declarative machine learning, which is the configuration-driven way to be able to train these models directly in the open source by trying Ludwig today. If you want to get access and get to the platform Predabase, which builds all the functionality around this kind of key capability, from data connectors to the model repositories to serving and operationalizing those models you saw hinted at today, as well as the infrastructure that supports them, please reach out to our team. We'd be more than happy to set up a demo and give you some access as well. So with that, I think let me conclude this part of the presentation and open it up for questions. And Sean, happy to turn it over to you if there's any questions we can help answer.
All right. Well, Dev, thanks for that excellent presentation. And we'll get started with today's Q&A session. I want to thank the audience for their participation. We've had a number of questions that have come in during the presentation, and we'll do our best to get through all of them in the time remaining. All right, so let's get started. Dev, the first question is, can you share some examples of how customers are using the platform?
Definitely. So we work with a number of different types of customers today. For example, we work with a large US national bank, a healthcare company in the US, and a number of tech companies. One of the consistent themes that we see with those customers is that they use it for use cases where they're trying to get more people onboarded onto machine learning platforms, a lot of time engineers, and in particular for use cases that deal with unstructured data. And so we think that an underrated feature of AutoML 2.0 is that it works particularly well for unstructured or multimodal data. So to give you a sense of the use cases that people are quite interested in being able to do, some of them involve like being able to classify, let's say, medical images based on like a combination of the medical image as well as the doctor's report that might go with it. Other types of use cases that I think we've seen, again, I go off this idea of being able to combine unstructured and structured data, but do so for something more like a recommender system, where I might have a description of a user, a description of something like a product or an item, and I want to be able to recommend to that user what someone would be interested in doing next. And then finally, the thing that I want to mention is there's a couple of examples of use cases that people have built in the open source as well, including the original thing that Ludwig was used for at Uber. And the original thing was used to build at Uber was to build a customer service automation agent that would take in not only the text from an input customer service query, but also metadata about the user. So, how long they've been a customer, what their ride was, and use that to be able to build a multimodal model. And so we see a lot of different types of use cases. Multimodality and unstructured data tend to be like the hallmarks of some of the most frequent ones that we see overall, though.
All right. So, Dev, the next question, it's a compound question. What platforms does your version of Ludwig operate on? Which PC operating systems, which cloud OS, AWS, Azure, GCP?
Yeah, great question. So Ludwig, the open source project, can run locally on Linux, PC, or Mac OS environments. You can look at the full documentation on how you can actually get started on the ludwig.ai website. And you can see everything from installation all the way through running, an initial experiment that will go up through your first model that you can actually serve and deploy. And I expect that you'd be able to get, a lot of users are able to get their kind of, first model within that afternoon. And I think it's an experiment very well worth doing. But Ludwig is very flexible in terms of where it runs, as is Predabase, our enterprise platform. We deploy directly on top of Kubernetes. And so we deploy into any of the three major US cloud providers. So we support AWS, Azure, and GCP for our commercial platform today.
All right. Thanks, Dev. So a question has come in that dovetails off of the first one, and that is, can you please provide a use case for government agencies? And then also, do you want to talk about a good starter use case, or do you feel you've already covered that?
Yeah, happy to talk about a use case for government agencies, for example. Now, we see government agencies have many different types of things that they're interested in. I think that one type of use case that reflects things that we've seen from government is especially in NLP and building something like a document classification model. And so we see a lot of users there that are getting inbound in terms of long form text, and they might need to be able to understand how they want to triage that internally. And so I would think, in a government context, any areas where, again, it can be instances where you have structured data or unstructured data, but I think where you see the most differentiated value is when you might want to do an NLP task, again, something like a document, or you're looking at doing something like image classification. I can only speculate towards the types of images, but if you wanted to do something like satellite image classification or other types of use cases directly there, I think it would be very easy for you to be able to get started in the platform, and you'd have all the flexibility you need as you go through. One thing I want to point out is, on the predabase.com website, we'll have a series of use cases and some examples of how you can build them coming out shortly in the next couple of weeks. So please stay tuned for that. But if you go to the Ludwig docs, you can actually see some examples of what this can be used to build directly. Anything from sentiment analysis to visual question answering systems to audio use cases and others. And so if you're interested to get all the way to fraud detection and many other types, if you're interested to get a brief flavor of like what these types of systems are able to build, some of these are directly available in the open source, and obviously more than happy if you want to reach out to us via predabase.com to talk about the actual data set and use case that you might have. More than happy to talk through how we might be able to help.
Thanks, Dev. The next question's come in. It says, how does this interoperate with data visualization platforms?
Okay. Yeah, good question. So I think the key way that we think about it is that we try to be as complementary to data visualization platforms as possible. And the way that we want to be complementary is we provide you some set of data visualizations out of the box, the ones that you saw earlier. And these are the data visualizations that we think are most important for machine learning tasks. So maybe things like your precision recall curves, confusion matrices, and feature importances. However, you might have a downstream process that does things like dashboards or data visualizations. And what you want to do is plug in your predictive, your predictions on top of that. In Predabase, the way that you can do that quite easily is you can set up a pipeline where what we'll do is we'll take that same PQL query that I showed you today. So like I'm going to add in this prediction on top of the normal table that I get. And you can actually write it out to a downstream table. So I can say I want to write this into, let's say, a Snowflake table. And what this will do is it will write out the predictions, this table, into a Snowflake table. And so any data visualization tool that you use that maybe pulls from an upstream data source like Snowflake can now visualize this additional piece of information, like the predictions. And if you want to run this on like a recurring basis, you can actually schedule these queries to be able to run, let's say every hour, every minute, every day. And so you can set an output. For example, I might want to output this into Snowflake or BigQuery. And then you can have a data visualization layer downstream that will pull from this upstream table and automatically populate the live dashboard. That's definitely one way to be able to do it. And if you reach out to us and you want to see a demo, we can also show you how, using this within, let's say, 30 minutes, you could build a very cool and slick front-end application with a few other tools that might be useful for the visualization of the predictions directly.
All right, great. So the next question is, can you expand on where customers see the most value, the biggest impact from using Predabase?
Yeah, definitely. So I think where we see customers get the most value or the biggest impact from Predabase is where they want to expand the set of teams that are able to use Predabase, still within a technical user base. So in particular, maybe like an engineering team or an analyst team that's ML curious. They have a use case that they're interested in being able to do ML for. That's high value to the business. For example, maybe a recommender system. They want to be able to personalize content that they recommend to someone, or for triage, for example, in the customer support type of use case. So that like there's two components towards, I'd say, discovering value. The first is expanding access to an audience that might not have been putting models into production otherwise. So maybe an engineering audience there. And then the second is being able to work on a use case, they get differentiated value, where there's some unstructured data. So they might want to use a large language model, for example, in order to be able to represent text and do NLP tasks, or they might want to do something with computer vision or audio. Those are all different types of data modalities that we support. So I'd say any area where there's unstructured data or multimodal data is likely to be one in which customers are likely to see large business value. And the types of tasks that we see concretely for those are very domain specific. But document classification can be one, product recommendation systems can be one, and then computer vision or image classification, especially for like things like predictive maintenance or others, is certainly another.
Well, thanks for providing that additional detail. The next question is, what types of personas at your customers use the platform the most or get the most value?
Yeah, it's a really good question. So I'd say there's three types of personas inside an organization that could interact with Predabase. And they get value for, at a different components of it. The three personas might be a data scientist, an engineer, and a data analyst. And I would say that the people who start using the platform initially tend to either be the data scientists or the ML curious engineer. And there, the value that they get is the massive simplification over the modeling development journey. Even the more expert data scientists, I think see a lot of value in the fact that the infrastructure is abstracted away. You never have to think about how you want to implement your own distributed training loop. And the fact that a lot of these model components are modularized. So instead of having to rewrite all of that code, even if you could write, those hundreds of lines of code, instead of having to rewrite all of that code, you can just package it behind a very simple configuration. That's on the data science side. On the engineering side, what we often see is now these engineers can use state-of-the-art cutting-edge models very easily, by selecting them in a single line configuration, and they never have to essentially, learn how to code in PyTorch in order to be able to do those. So those are the two types of personas that we see most often, enter the platform and get involved. And then finally, we see analysts use it in particular once a model is trained in order to be able to query it. And so if you wanted to, for example, say, I'll create a model that will do Twitter bots, but there's an analyst on my team who's looking at bot detection as a broader problem, and they want to understand where is the model, or what are the key factors driving bot creation, what types of users are more likely or less likely to be considered as bots. This type of interface becomes a lot easier for them to be able to open up. So to summarize, I would say there's three types of personas that could get value. We tend to start with either a data scientist that wants to make some part of their life easier, or an engineer who's looking to up level in types of the capabilities that they'd be able to develop on their product.
All right, well, thanks for providing that background, Dev. So I think we have time for one more question. Does Predabase support large language models like GPT?
Yeah, it's a really good question. And the short answer is yes. And let me show you a little bit about how actually, maybe in a brief demo, how exactly we can support those. Again, it becomes easy for us, or it becomes easy for any user to get access towards these directly from our UI or through the configuration-driven interface that maps to. So our machine learning pipeline allows you to use a best-in-class model for every type of data that you see as input. So I can use the best-in-class text model with the best-in-class image model. For text, you can select any of the number of models that we support. Support a number of the large language models. So something like GPT and GPT-2 and others are definitely supported. These can be quite large. And so while they are effective to be able to train, if you want to fine tune that and compare that to other models in your data, like Transformers or BERT or DistillBERT or T5, which is a model that came from Google, we allow you to essentially select any of these directly from a drop-down menu. And one of the really kind of cool things I think about this is that you can select a model and then decide to use it pre-trained, which means you'll get all the prior benefits of its model training, but then also fine-tune it on your data set. And so this allows you to essentially customize a larger language model onto your data set. And the last thing I'll leave you with is that this works not only for large language models, but the other types of foundation models as well. So I can use, I can apply the same type of principle to like an image feature as well. So I can use something like VIT, which is one of the cutting edge vision transformer models, also use it pre-trained and then fine tune it onto my data set. And I can package these into the same modeling interface and use them jointly. So I think it's a really novel way and a really useful way for people to not only use large language models, but also customize those large language models for their data set.
All right. Well, Dev, thank you. Great answers to some very good questions. And for those of you that asked questions that weren't answered today, we will be sending all unanswered questions to Dev and the Predabase team so that they can follow up with you after today's webinar. Also, today's taping will be available for on-demand viewing later today and can be found on the homepage of Data Science Central in the webinar tab located at the top of the page. And past webinars are available on demand at datasciencecentral.com. If you haven't had the opportunity to view them, I encourage you to take a look. They provide very useful insight into a wide variety of topics of interest to our data science community. Well, this brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions, and a special thanks again to Predabase for their sponsorship, as well as to our speaker today, Dev Rishi, for his insight into today's topic. My name is Sean Welch, and I'm very pleased to have been your host for today's event, and I look forward to seeing you all again on DSC's next webinar. Have a great day.